So no calculus at all on today's assignment. Completely trig, but trig that sometimes we struggle with. So you know what? Let's back all the way up to x squared equals 9. That's not trig, but if x squared equals 9, what does x equal? Plus or minus 3. Good. On the other hand, if I just have, so separate question, if I have square root of 16 sitting there, what's the answer to square root of 16? 4. Not plus or minus 4. Just the positive 4. When it's in an equation, we could have more than one answer. When it's given as, like this is it might have even been better to say this is a function. Functions can only have one answer, or else they're not a function. Like the old vending machine example. If you push the 16 button, you have to know what you're getting. You're getting a 4 out, not a plus and a minus 4. So that's a little bit tricky, and it's related to if we have sine of x equal 1/2, unit circle experts, where does that happen? Remember what angle has a sine of 1/2? Anywhere else? The answer is yes. Maybe a picture helps. Taxing your brain, yes, 5 pi over 6. And really, it's more than that. Those are the only two places on the unit circle. But if we wanted to get creative, we could go backwards and do negative 7 pi over 6. ... There's an infinite number of correct answers. On the other hand, if I ask for the inverse sine of 1/2, that can only have one answer. I can't, if I type inverse sine into my calculator, it can't give me a bunch of different answers. It has to give me one answer. Kind of like the square root only gives me one answer. So of those answers, which one do you think would be the simplest, easiest, most straightforward pick? Pi over 6. All right, so let's do some more unit circle problems, and then we'll do some picture problems. This is kind of funny because this is the exact lesson we did yesterday in pre-cal, or 2 days ago, something like that. Let's do the inverse sine of the negative root 3 over 2. Inverse sine of negative root 3 over 2. It goes down. Remember, sine goes with y, so it's up and down. In fact, in pre-cal, I've started asking what quadrants have a negative sign, and people started just saying the down quadrants. Yeah, it's quadrant 3 and 4, but saying the down quadrants is maybe even more helpful. The down quadrants. So, more specifically, though, which angle has a sine of negative root 3 over 2? Okay, it's definitely over 3. Now, do you remember which one you want to use? Like you can go this way, you can go this way, you can go backwards. The answer is always what's the quickest way there? So what's the quickest way to get to one of those angles? Negative pi over 3. Negative pi over 3. In fact, when we're doing inverse sine, we will always pick from quadrant 1 or quadrant 4. And if we're in quadrant 4, we'll use the negative numbers. So our answers for inverse sine will always be between negative pi over 2 and pi over 2. Because you can only have one answer. You're not allowed to spin around and go way around and backwards and get the quickest answer possible. That's the easiest way to remember it is get the quickest, easiest answer possible. You'll almost always be right. All right, how about inverse cosine of negative 1/2? Inverse cosine of negative 1/2. What quadrant might that happen in? Where is cosine negative? 2 and 3 are the left quadrants. Let's see, cosine is the x value. And that's a short side, so I want my x's to be short sides. So steep angles, that's what's going through my head when I try to figure out exactly what angle it is. So pretty sure the quadrant 2 angle is the easier one to talk about. So what angle is that? Goodness. It's the tall one, so it's over 3. It's the steep one, so it's over 3. Goodness, that's why we spend a whole day on this. It is 2 pi over 3. It is 2 pi over 3. 1 pi over 3 would be right here. Because 1/3 is less than a half.
I'm thinking that there's 3 of them in the whole circle rather than 3 of them in the half.
3 of them in the top half. 3/3 in the top half, yeah. Inverse cosine is always going to come from quadrants 1 and 2. So 0 to pi. Inverse tangent of negative 1. Tangent's a little bit harder, but of 1 means that sine and cosine are equal to each other. So it's something over 4 for sure. And tangent is negative in the second and fourth. Because in the third, sine and cosine are both negative, so the ratio becomes positive. Well, here I guess you could argue that it's, this one's negative, but it's closer. The other one's farther, but it's positive. For inverse tangent, you still want the shortest way there. So negative pi over 4.
So it doesn't matter if it's negative or positive, you just do the.
Yes. Well, cotangent is the only exception to that.
And then if you like the same distance, then you do the positive one?
Correct. So pick the closest one as best you can, even if the negative one's closer. And if they're sort of equidistant either way, pick the positive one. The only exception to that is cotangent. In fact, here's the summary picture of this lesson from pre-cal. If you're in quadrant 1 and 4, or excuse me, I should phrase that differently. Inverse sine, inverse cosecant, inverse tangent are quadrants 1 and 4. Your answer will come from quadrant 1 or quadrant 4. Quadrants 1 and 2 are the other 3. Inverse cosine, inverse secant, inverse cotangent. Cotangent is the only one that's a little bit weird, but it's rare you have to worry about that. do a quick, hopefully quick, recap or review here. Some sample problems for you. So try those three. Inverse sine, negative root 2 over 2. Inverse tangent of square root of 3. Inverse cosine of negative 1. That's a good point. Each of those mean find an angle whose sine is negative root 2 over 2. But you have to pick it from, where you're allowed to look. Find an angle whose tangent is square root of 3. Find an angle whose cosine is negative 1. Alright, so that's unit circle questions for you. The second type, I think, is easier because they're not unit circle. In fact, that's Roman numeral 2, not unit circle problems. And you'll have to draw a picture. But most of you would rather draw a quick picture than think about the unit circle. The sine of the inverse tangent of 3/4. Inverse tangent of 3/4. Okay, that's not a unit circle value, right? There's no angle whose tangent is 3/4. But I do know that tangent is opposite over adjacent, or y over x. So I can draw a picture, and I'll make the y be 3 and the x be 4. Or the opposite is 3 and the adjacent is 4. You can use SOHCAHTOA, or you can use x and y's and r's, either one. And so you'll use the inside info to draw a picture. And then you'll use the outside one to answer the question. What's sine in terms of SOHCAHTOA? Opposite over hypotenuse. So I look at my picture. Well, I'm kind of missing something, but not a hard something to be missing. What's the hypotenuse? 5. If you need to do a squared plus b squared equals c squared, you can. But opposite over hypotenuse would just be 3/5. No unit circles were harmed in the making of that problem, though. Cotangent of the arc cosine of negative 2/5. I guess first of all, arc cosine means the same thing as inverse cosine. So let's draw the picture. Oh, and I have this in my notes because some people don't like the arc thing. So they will literally rewrite every arc as an inverse. And that's okay. It's overkill and unnecessary, but if that helps. Let's see, cosine is adjacent over hypotenuse. But inverse cosine, I'm supposed to be in the first or second quadrant. Where should I draw this picture? What quadrant has a negative cosine? The second. Second and third, but the second would be the easiest. So it's still kind of that logic of, do the one that makes the most sense. So adjacent over hypotenuse, or x over r. Adjacent's negative 2. R is 5. Well, this one's not as easy. Although some people will try to tell me that it's a 2, 3, 5 triangle. A squared plus b squared equals c squared. So 25 minus 4 is 21. Well, it could, that wasn't a 3. If that was a 3, then it'd be a 3, 4, 5. Yeah. It's a 2, so it messed this up on the pattern.
Oh, okay. Never mind.
So sometimes we give you nice ones where it fits the pattern and it's easy. Other times we force you to do a little bit of Pythagorean theorem to find the missing side. All right, so we've drawn our picture based on the inside information. And then cotangent. What's cotangent in terms of... Oh, I heard them both, and both are right. Adjacent over opposite or x over y. And that means the same thing as long as you can keep x and y situated with adjacent and opposite. Let's see, x is -2, y is square root of 21. And in pre-cal we'd have to fix that, but this is calculus, we leave it alone. Let's do one more. The sine of the arc cosine of 2x. Sine of the arc cosine of 2x. Okay, so this one's different on a couple of fronts. It doesn't have numbers in it, it has letters in it. It's also not a fraction. A over h, x over r. So I guess I'll just deal with the x as it comes, but how do I make that a fraction so that I can match up adjacent and hypotenuse? What do you think? Ooh, that would be really tricky if you made that 2 over x to the -1. I don't know if that would work or not. I think it would, because you're right. But what would be an easier way to make that a fraction? Let's just put it over 1. Now I'm curious about your suggestion, but let's go the easy route. So the adjacent is 2x, the hypotenuse is 1. Sine is opposite over hypotenuse. Oh, darn it, so I need to find the opposite. Well, it still works the same way. It's still a squared plus b squared equals c squared. 2x squared plus b squared equals 1 squared. So b squared equals 1 minus 4x squared. So slow it down a little bit because this is a little more complicated than just numbers. But it's the same process. It's still Pythagorean theorem. A squared plus b squared equals c squared. I don't have to worry about the plus or minus because the way I drew my picture, I'm going to make it, if I have the choice, I'm drawing it in the first quadrant, everything's positive. Opposite over hypotenuse, so square root 1 minus 4x over 1. Obviously the over 1 isn't necessary, but sort of emphasizes that this is opposite over hypotenuse. Okay, so no derivatives today. No inverse, no integrals. Just a recap of trig. Again, everything we did today was like 3 days worth of pre-cal that we're doing right now in pre-cal. Page 372, 3 through 9, and 15 to 25 odd. And again, that is all pre-cal review. It's just we kind of insert an extra day in here before we start doing derivatives and integrals to remind ourselves what's going on with inverse trig.